to Ken for the start of this session on networks.
Thank you very much. Thank you for the invitation and for being here on the morning after the conference dinner. I found it a bit of a struggle. So Matten, Shweta and I have vaguely coordinated our sessions, and we'll attempt to seamlessly run one into the other, although in practice I'm sure we'll fail. We did consider doing a sort of tag team thing up here on the stage, and then we saw Julia and James try it, and we thought, we thought we couldn't possibly match that, so we shan't. But there's been quite a lot of mention of networks as concepts and ideas throughout the meeting so far, so I thought it would be a useful thing to have in this session some discussion of actually how we go about measuring these things. So that's what I'm going to talk about for the next 20 minutes or so, and the usual apologies, it's going to be a personal and partial and prejudiced account of things that I think have influenced me and that I think might be interesting things for the future, but I'm sure there's a lot of other stuff that people can contribute, and this is not supposed to be the solution to anything or everything, really. The obligatory photo. So in 1993, I was as stylish as I am now, unfortunately. Okay, so I want to talk about ways of measuring social networks relevant to the spread of transmission, spread of some kind of infectious disease, and I'm thinking mainly about kind of face-to-face respiratory type infections, not so much about sexually transmitted things. And I know Martina has talked about that already in this meeting, so thank you for that. It's nice not to have to cover absolutely everything. So I'll talk about some ways of measuring networks, some complications that probably ought to be thought about at least, and then maybe some other ways of making some progress. Okay, so as far as we're concerned, I think a network is a set of people in a population and the interactions between them in some way relevant. This is a social network in a primary school somewhere down in Kent. And we're thinking of these. The importance of networks for epidemic purposes, rather than just thinking about a population that mixes, is the fact that, as Martina's already talked about, once infection is spread along a link, in some ways that link is used up, and it's not going to spread along it again because you've got either two infectious people or somebody recovered or something, so it doesn't really have any epidemiological function anymore. So that the relevance for epidemiology is the fact that these networks are kind of fixed, although actually we know they're not. Okay, so simplest way of setting it up, we have nodes, people, but they could be animals if you liked, and we have links between nodes. And we know that these nodes have attributes, age and gender and vaccination status and location, all that kind of thing, and links have attributes as well, so we know there's a duration and a frequency of contact, some kind of stability of that connection, how close people are when they meet, when it is they're coming into contact with each other. So actually, even writing it down, kind of first thing you'd write about a network, you realise that the assumption that you've got this fixed set of contacts between people in a population can't possibly be right. You know that people are changing, you know that the contacts are changing, so really the networks that we're ever going to experience are going to be not fixed and well known, they're going to be dynamic things, and the link is going to be different for different people and in different places. So that's extra complications that we should probably care about if we're going to build models of epidemics on networks, because our simple assumptions we know aren't right. Maybe they're fine, but they're not right. Okay, just a nice example. This I think is one of the first networks that I came across when I started thinking about this kind of thing back in my PhD days, and this is a network of sexual partnerships in Canada in this paper by Wiley and Jolly 2000, and each node in this network has been given a couple of properties. So we know their gender, there's M's and F's there, I'm not sure if you can see that at the back, and we're also told their infection status for chlamydia and gonorrhea. So people with unknown status are marked UNK, females are marked F, so there's a lot of nodes here marked FUNK, which I don't think has anything to do with Sebastian, but you do think. Okay, and this network came out of contact tracing work, so if you turn up symptomatic or suspected symptomatic in a clinic, then a good way to control infection is to find the people, find your sexual partners and attempt to treat them, and that gives you potentially quite a lot of data about how people are connected together. So there are a lot of networks out there that are basically contact tracing networks, and those are really interesting. Partly because you get all this information about connections, and partly because you know something about people's infection status, but they're probably not the best way of collecting social network data in general, because you tend to end up focusing on the places where infection is, which is a good thing for disease control, but it's not such a good thing for a general description of the population. Anyhow, fascinating stuff in all of that. So, I'll talk about a few different ways of measuring networks. You can do an observational study, so you could sit in a school and watch what the kids are doing in that school and make a note of when they come in close enough contact, if you want to. People have done it in nursery schools in Mexico, I think. You can do the contact tracing stuff, which we've talked about already, and then I'm going to talk in a little bit more detail about contact diaries and about electronic measurement of networks. So contact diary stuff. Lots and lots of work has gone on this in the last few years. John Edmonds was, is he around? Can't see him this morning. So John Edmonds did a lot of this work in the build-up to the polymod study, which I'm sure most people are familiar with. And basically, contact diaries are dead simple. You get people to write down a list of the people they've met. Who have you met today? Write their names down. Couldn't be simpler. It gets more complicated in practice because while you've got these people filling in surveys for you, you might as well ask them more questions as well. So rather than just getting a list of names, you ask for information about the person that you're meeting. So you tend to ask their age and their gender, that kind of thing. And you ask them information about the encounter itself, so whether there was physical contact and how long it lasted and where you were and how often you meet this person. And partly it's because this is useful and interesting stuff, potentially. And partly it's an understanding that actually just having a list of names doesn't tell you everything you want about the interaction. You'd like to know more. And you're not quite sure when you start out with these studies which of these things, if any, actually matters, but you suspect that all of them do. There's good sense in asking all of these questions. Okay, so and it's massively low tech, which I think is quite an advantage for any network study. That in a lot of settings, clever high tech things just don't work, and people are quite familiar with writing things down on a piece of paper. So it's kind of straightforward, and it seems to work. I'll talk a bit more about ways in which it doesn't quite get things right. Okay, so on these contact diaries, so long as people write down the names in this "Who did you meet" column legibly, and they know what people are called, then you can turn this into a network. You can link up people who are connected together. So, a study that John Evans did in Warwick University back in 1990 something or other. He got 50 people in the biological sciences and maths departments to fill in these contact diaries, listing by name everyone they met over the course of a day for 14 separate days over 6 months. And they got a network out of it like this. And you can only do this because you've got names written down, and you can only really make it into a sensible network because you've restricted your area of interest to the biological sciences and maths department. So if you went out into the general population and found 50 people and got them to write down the names of the people they'd met, you're not going to learn much about the network because chances are none of the people they meet are included in the study or are met by anybody else. So you can only really get networks out of this if you do it in fairly limited, fairly restricted settings. And there's good reasons why you might care about restricted settings. You might be interested in a school or a hospital or a nursing home or something like that, where actually it makes perfect sense to look restricted to that setting. But it's not going to get you at the whole population. That doesn't always matter. So if what you care about is how different age groups mix together, then the fact that you're not getting the network isn't a huge problem. And that's the motivation for using this kind of contact diary study, contact diary method for the polymod study. They weren't expecting networks out of it. They didn't care about people's names. But they want to know how different age groups interacted. And I'm sure you've seen the pictures. This is one I nicked from Pedge and Aaron, which is very lovely. So this illustrates the fact that when you look at mixing patterns, you get strong like-with-like mixing within age groups. Most of the mixing is school kids with other school kids. Then you get these off-generation diagonals. This charming picture here of a man about to strike a child around the head with a large wooden stick, I'm assured is some kind of American leisure activity. Anyhow, marvellous stuff. So it doesn't matter that we don't get network data out necessarily. This can still be really useful for the models that we're trying to build, and it's kind of been the basis for the sort of detailed age structure models in the last few years coming from this kind of survey. And so going back to some of the stuff that was talked about over the last few days, if we believe that simpler models do a good job, and quite often they do, then we don't need a network. We're happy with our simple model. We'll have age structure, measure the mixing between age groups, bung it into a model, and that will do a nice job. And you could think of using this kind of contact network, contact diary data to give you information. It's a different sort of network here, so you could think about how different age groups in different towns are interacting, and you can measure this sort of thing with a contact diary without needing to know people's names, just need to know where they live and how old they are. And you could kind of heuristically think about this as a network if you wanted to, although I think I wouldn't from an epidemic point of view, because once infection has passed from a young person in town B to an old person, this link is still there and still active. There are still lots of other young people and lots of other old people who could be infected via this connection. So it's not quite the same as thinking of networks as links between individuals. But it's a useful thing we can do with that data set. So this has been extended in the last few years by big study run by Matt Keeling and John Reed and Leon and Thomas and other folk in Warwick, where they produced a rather prettier contact diary. It looks like this, but same sort of principle really. What's changed here is they ask a question about clustering within the network. So this, you probably can't see it. The question here doesn't just ask you to list all your contacts. It asks you to write down which of those contacts know each other. Okay, so I've met Seb and I've met Gwen. Do Seb and Gwen know each other? Yes, they do. So I can fill that in my contact diary. And there's times when you think, well, I've got quite good information about which of my contacts know each other. It's not going to be perfect, chances are, but there's some quite good information. It's a bit of a, I hope you don't mind me saying, it's a bit of a pain to fill these things in sometimes. If you've listed 50 contacts, then you've got to fill in a 50 by 50 clustering matrix, and that gets a bit tiresome. I mean, no reason why you couldn't do it if sufficiently motivated, but it's quite hard work. Anyhow, but that takes us a step beyond just the number of people you meet, because it gives us actual network information, at least local network information. And they get out, this is a slide I nicked from Matt, there's information comes out of this, telling you things, for example, about the clustering in different social settings. So you can look at, you've got social groups which are highly clustered, you've got workplaces which are clustered, homes which are clustered, but there aren't these cross links between different settings, and that presumably potentially can have some impact for how we understand epidemic spread between different sorts of locations and different populations. So that's where we can go with these contact diaries, and I think they're a nice low-tech way of gathering information, and you're very lucky you'll have a chance to try these out for yourselves in due course. Okay. There's some more high-tech stuff out there. There's always a high-tech solution to things. So electronic tagging of whatever has come into practice in the last few years. So back in the early days of these things, these electronic tags were big clunky things and the batteries weighed half a ton, so you could only really apply it to an elephant. Or seals, it's sea lion, where the thing floats around the water. You can see a little antenna poking out there. But these things are getting better and better and smaller, and there have been studies done using these tags. This is a load of tags people wear on rather like your name badges here, which sadly aren't electronically tagged. I wish they were. So this is an experiment done in a science museum as a public engagement thing, but it's been used in hospitals and in schools to measure direct proximity. And in fact, these things are now so tiny that you can stick it onto an ant and radio tag an ant. I don't know the technical details of this stuff, but I think that's completely brilliant. If I were having my photo taken, I would have cleaned my fingernails. But apart from that, I think this is fantastic stuff, giving all sorts of extra information about contacts. We tried doing it with Bluetooth as well on mobile phones, because almost every phone, apart from the one I used to have, had Bluetooth capability. So if you turn your Bluetooth on, it tells you what other devices are switched on and discoverable in the local area. So you can measure networks in some way, or proximity in some way through that. There's advantages and disadvantages to these things, as there always is. So the Bluetooth stuff, when we tried it out, it seemed to work fine, and it's kind of a cheap add-on to what people have already got, but it's a bit too long range. So it's supposed to be data transfer between devices, but it has a range of 10 meters or something. It goes through walls and floors. So when we did this experiment, this little pilot thing down in London, we found we were continually connected to the person sitting a floor above us, even though we'd never met them or didn't know their names. That was a bit disconcerting. So the way these radio frequency ID tags are supposed to work is that if you're too far apart, these people are too far away, they don't make a contact. These people there's a body in between, so you don't make a contact there, but you only record a contact where people are actually face to face with their tags facing each other. That's how it's supposed to work anyway. And the advantage of having these custom designed things is that you can then tune them to record at the range that you want, and you can demand that it searches every 5 minutes or 2 minutes or 30 seconds or hour or whatever it might be. And these so one of the problems with the contact diary stuff is that you can't really get people to fill it in day after day or hour after hour. You can't run a survey and say, well, who have you met in the last 10 minutes? And now who have you met? And now who have you met? Because people club you to death with their massive diary forms. But you can do it with these radio tags. So you can set it to record dynamically, so you can get some measure of the changes that take place in networks over the course of a day or even the course of weeks if you have your battery sufficiently lively. Okay, so that's a quick glance at electronic measurement of social networks. There are other kind of proxy measures of social networks that have been looked at and thought about. So you could look at phone call data, so not phone proximity, but who you call on your phone. If you get the data from the mobile phone companies and you know exactly whose phone is calls or text whose, well, that tells you something about a network. You might argue that network may not have any relevance at all directly for disease spread, because you're not going to transmit flu via your mobile phone, but I wouldn't have thought the people you phone and the people you talk to are completely independent things, so there's probably some kind of correlation in there somewhere. It's difficult to tease out exactly what that might be, but it's another source of network data that people are potentially interested in. You could do the same thing with social network data, so looking at Facebook contacts or Twitter contacts and all that kind of stuff, with the same advantages of having this big data set potentially out there and the disadvantages that may be completely irrelevant. People think about travel patterns as well, so there's been some nice work looking at airport transportation networks linking airport to airport and how kind of global movement. And again, I wouldn't think of that particularly as a network in the most immediate sense, but it tells you about links between different cities, and if you've got a city-based model of pandemic flu, then it's quite useful to know how different cities are connected, and these things seem to give helpful signals when understanding global spread of infection. You can do a little bit more locally, looking at commuting data, so where people travel from home to work and all that kind of thing, and I know, again, folk in the Warwick group, and I'm sure others have been looking at that sort of information. And again, so that doesn't tell you exactly what you want, because really you want to know how kids mix with other kids, and you're getting how grown-ups go to work, but it tells you something about the links between different locations spatially within a country, for example. So it's another valuable source of network data. And similar sorts of things, I'm not going to talk about animal networks in any detail, but the cattle movement information that we have, for example, that tells us not quite how cows are linked to cows, but how cows' movements link farms together, is another kind of direct estimation of movement between patches, I suppose. So another nice bit of work is some co-location time use data. So if you know that people start their day at home and then they go to school and then they go to the park and then they go home again, and you know for your population of interest where people's homes and schools and parks are, then you can come up with sort of this time use information. So you're linking people to places. So a little cartoon example here. So at time 1, person 1 is in location A and so forth. Time 2, people moved about a bit, and you can use this information to then reconstruct a network based on co-location. So here, well, you can see what comes out of it, but people are linked by sharing a location at a particular time. You can do more with this stuff, so it's dynamic as well. So this network is really chopping out a load of the information. And if you were worried about the fact that your infection doesn't just spread through immediate contacts, but there's some kind of contact to surface to later collection of infectious agent thing, then you've got the information there as well. It tells you that person 1 visited place B 1 time step after person 3 was there, and in person 3 sneezed on the doorknob on his way out, and person 1 wiped his eye having opened the door on his way in. Well, maybe there's some information about infection there too. The difficulty I have with this sort of network is that knowing people are in the same location, if that's a school or a workplace, I don't think that's enough to tell you that they're actually in any kind of meaningful contact, nevertheless. Okay, so there's a load of issues that we've kind of touched on already about network data collection. If you've got lots of contacts, it's really hard to recall them, and it's dull to write them down. Accuracy falls apart a bit, so if you've got to give information about the person you meet, that information is a little bit dodgy, potentially. If you're listing names, that can all go horribly wrong, because there's quite a lot of John Smiths in the world, and how do you know which one it is? the boundary of the network is a difficult thing to deal with. Where do you stop your network study? And really a big problem here, which I'll talk about in a little bit more detail, is a definition. How do you define what a contact is? And I'll come back to that in a moment. So some of these things we can get over with the more technical solutions, others we can't. And I think whatever we do, there will be issues that we have to deal with. Okay, so there's other stuff that matters. So networks change kind of through births and deaths, through seasonal changes, through day-to-day stuff that you know about and stuff that you don't. This is more stuff from John Reed. Number of contacts people make in a day, and it's the same person reporting on 14 different days, and you can see that your daily contact patterns change. You know that stuff. And if you think about it, the more dynamic this network gets, then maybe the network starts to matter less, and we can return ourselves to simpler models. Okay, illness matters as well. So when you're sick, you do different things from when you're well. And really, if we want to understand the spread of infection, we probably care about what people do when they're sick. So measuring what people get up to when they're healthy is perhaps not the best thing. This is a slightly difficult to explain figure, but I'll try to do it. So we sampled people when they were ill and when they got better, and we measured the number of contacts they did. It wasn't a network study, it was a mixing study. So when people are at home, blue line is the number of contacts. So people's number of contacts at home doesn't seem to change when they're ill, but the number of contacts people make at work, for example, falls from 5 to half a person when they're sick, because obviously people don't go to work. So you can imagine that your social network is moving from your standard day to a sick day, and your sick day means you stay at home, which might mean that the stronger contacts you make are the ones that matter, because they're the ones that happen at home, and they're the ones that are retained when you're ill. Okay, so we get to a slightly more philosophical point, I suppose. What do we really want from these networks? And really, what we want is how people mix, but that's such a woolly demand that I'm not sure that tells us a lot. And actually, what we really need to know is who you would infect if you were infectious with whatever your topical pathogen is. Okay, but we're never going to be able to measure that. We might be able to measure who you meet and perhaps put some weight onto that connection, but chances are we can't do that either. So in fact, we probably can't measure who you meet when you're ill. We can measure who you meet on a normal day. What's a normal day? Who knows? So we're going to measure mixing now. And what on earth do we mean by a contact? Well, we're not quite sure. So we're going to measure what we can. And in most of these surveys, there's a fairly arbitrary but sensible definition of what a contact is. It's talking face-to-face, or having a skin-to-skin physical contact with, or being within 3 meters of. But that's not the right thing. That's a sensible thing. And the reason we ask that is it's a combination of what we can sensibly ask people and what they can tell us. So you ask a question that people can answer, and I think that's what you have to do. But we know that there's things going wrong with that. So what we would like to do is to link the contact behaviour to infection. We want to know what it is about social contacts that actually leads to somebody getting infected. And some work is starting with linking some contact surveys with some surveillance and swabbing work to try to get at what part of social interactions is really important for the spread of infection. Okay, even when we do this, it's not going to be the same for every infection. So contacts that matter for flu are clearly not the contacts that matter for chlamydia. And it's not going to be the same in different populations at different, or the same population at different times, or different population at the same time, probably. So I think in the end, what we're after is a robust proxy for what contact really is. So that might be your talking face-to-face. Maybe that's a good enough correlate with what really matters. Maybe it's not, but the studies need to be done to be completely sure. You've seen this picture already. So this is a contact tracing network. There's no infection. There's no genetic stuff in this network. This is just people linked through social contacts, where a social contact is someone you've hung out with in the last year, potentially. When you try to do the genetic stuff, it's fascinating. I don't understand all this work in any kind of detail, but it doesn't make everything clear, because you would expect that people are linked to people who are closest genetically, whose infection is closest to them genetically, but that's not the case. So the purple links here are supposedly the social contacts in this network, but they're clearly not between the closest genetically. So more work is necessary to understand what we're getting from this. It's TB, so I guess it's complicated because of timescales and all of that. This is a slide I pinched from Adam. Thank you very much. So it's work from the Fluscape project, which many people in this room are involved with, and they can talk about it in better detail than I can, but there was information about people's contacts and whether or not they seroconverted during the 2009 pandemic. So you can see that actually people with larger numbers of contacts, maybe they seroconverted more than people with fewer, but there's age in there as well. So it gets complicated again. And what we would really like is to get at it in more detail. So we want to know people's contacts today and whether they get infected today to tell us something about which contacts matter. And the chance of doing that in a big study in detail is fairly low, but let's be ambitious, why not? Okay. I'm not going to talk about this in any detail, but we would like to be able to link networks to models and models to genetic data and data back into networks and go round and round to use the models to tell us which bits of networks we need to measure, use the networks to tell us which links we think matter, and have a load of feedback loops coming to that. This is a slide I pinched from Shweta, who can talk about it in more detail. So, some things I think we ought to do. There are a load of low-tech gaps in our understanding of social networks. So simple things to do with what happens when you're sick and what happens as the seasons change and what happens if you perturb the system. If there's a pandemic going on, run for the hills, what do people do? What does that do to your social network? And I think there are low-tech ways of trying to answer some of those questions. The modelling, I think, can guide us in the data collection we do. So you build a big, complicated model, including everything in it. You try to work out which of that everything matters, and then you try to collect that information. That seems to be the way forward. More connection between our models and our thinking to outbreak data would clearly be a useful thing, especially if we can get down to the individual level in some detail. And as the electronic stuff has demonstrated, that innovating and collecting social network data is clearly possible. There are always privacy and anonymity issues that are going to come into it, and I think we probably have to be sensitive to those. People get a little bit wary if you try to electronically tag their children. I don't know why. Okay, so that's the list of things I think it would be nice to do with social network measurement. I'm sure there are lots of other suggestions that people can make. And just to finish with a blurry quote that I've reproduced below, this is from Sally Blower, a comment in the book from the last meeting. So it is essential to begin joint studies that involve epidemiologists, biostatisticians and modelers. Maybe such an approach would make everyone hold hands, smile and produce something novel. Now, I'm English and a mathematician, so I'm not in favour of this holding hands thing. But it goes back to the point that Mark Woolhouse made yesterday, that linking what we do to the data collection is clearly important. If we want the right data for our models, we can't just sit around moaning. We need to get out there and work with people to collect it. Collecting it yourself is quite instructive. I'm pretty sure I'm not the best person to collect social network data, but it's a great learning experience to do it. So I would strongly encourage anyone who bemoans the lack of data in their models to actively attempt to do something about it. And I will finish there. Thank you very much.
What I'd like to do, given that the three speakers in this session have sort of coordinated their talk, is just to take most of the questions and comments at the end of all three, but just now ask if there's anything very specific that people want to ask Ken, remembering you'll have an opportunity once we've heard all three speakers.
Has anybody tried the control experiment approach? I mean, letting one infected and one susceptible speak to each other at 1 meter's distance for 5 minutes and see how often infection is transmitted?
Well, so I think it was done. There was this common cold research lab that was closed. Margaret Thatcher closed it down in the 80s. It was down on Porton Down, I think. So I think they did exactly that. They gave people a cold and made them share a flat or a bed or a living space with somebody, and then looked at what happened. And that's fascinating. I think that's wonderful. But the trouble is, you would probably want to do it for every single infection. So you'd want to do it for colds and for flus and for everything else. So I think it definitely gives you some information, but not everything. And
they did this at University of Virginia as well. A guy named Elliot Dick had people play cards, and sometimes they couldn't touch their cards. So on, with common cold.
Yeah.
So sorry if I sleep and missed you mentioning it. What about contact tracing? Because I was thinking certainly in the early stages of disease, when people do some fairly determined contact tracing these days, and I was thinking the kind of things that it's difficult to pick up with the social contacts. I mean, like all those people you met on the tube. Well, maybe or the aeroplane, which may well be the way that you get flu or SARS, some diseases. So.
Yeah, so I talked about contact tracing ever so briefly at the start, and I think it has a lot of value and gives you information.
The
trouble is that contact tracing is not normally done as a way of getting network information. It's done because there's an outbreak that we're worried about, and you therefore focus on what you think the important connections are, because that's where you're. So that's a bit of a circular
The
argument.
two things should inform you.
Oh, definitely.
The difficulty that we have with contact tracing is